Hey everybody, today I have actually a few updates for you all, specifically about the usage of the do-it-yourself Susan Shore tinnitus device by me and three other people. These three others are going to be remaining anonymous, by the way, to kind of, protect their privacy. But first, before I do that, I want to give a small description and explanation on how the Susan Shore device works. And if you actually care about this, then don't skip this part because it's extremely important for understanding how and why the Susan Shore device works. So let's get into it. Anyways, as you can see on the screen, we have like a diagram of the brain. And to explain how tinnitus is generated, let's start with explaining how sound is, understood, quote unquote, by the brain. So, as we all know from 8th grade biology class, inside of our heads or inside our ears, we have the cochlea. Now, this little snail-looking thing, is filled with little hair cells that respond to noise, and there are neural synapses that are connected to these hair cells that then take the signal and lead it into our brain stem. That's right, noise does not immediately go into the auditory cortex, even though our ears are like right here. It goes all the way down, and then it goes all the way up. That's how it goes. Now, if we talk about the cochlear nuclei, which are shown here, we have the ventral cochlear nucleus and the dorsal cochlear nucleus. Now, for the Susan Shore device, the dorsal cochlear nucleus is the more important thing. However, since I have a little theory about Susan Shore's device and why it has helped some with their hyperacusis and maybe even potentially noxacusis, even though we don't have any actual examples right now just yet, the ventral cochlear nucleus is, this part. It's actually responsible. It has a very important role in processing the timing and intensity of sound signals. Now, unfortunately, there's not a lot of scientific research papers on hyperacusis, loudness hyperacusis specifically, and the ventral cochlear nucleus, but we can all basically assume that, not assume, these are not like loosely based assumptions, that based on its functionality and based on how loudness hyperacusis behaves, a lot of it is actually dependent on this specific cochlear nucleus. Now, if we move on to the dorsal cochlear nucleus. Now, the dorsal cochlear nucleus is the part of the auditory pathway which processes the sound information. And not only does it process sound information, but it also processes something called somatosensory information. So what that means is basically information of touch. So for example, in our brains or all over our heads, we have stuff that is called cranial nerves. And these cranial nerves, by the way, the auditory nerve or the vestibulocochlear nerve is also a cranial nerve, as you can see here. It's cranial nerve number 8. It is also a cranial nerve. So we have multiple cranial nerves all around our head, and also that go down to specifically the cervical nerves that also go through the dorsal cochlear nucleus. And so because the auditory processing and because the somatosensory processing is connected so close together through the cochlear nuclei, specifically the DCN, some types of conditions or combined conditions or anything like that can actually lead to the synchronization of something specifically called the fusiform cells in the dorsal cochlear nucleus. And the synchronization of these cells consequently leads to the phantom perception of noise. Yes, it's like electric noise, it's like too much information basically is sent to the upper auditory cortex, and all of this is processed in the dorsal cochlear nucleus, which is why the Susan Shore device specifically focuses on it. So if we talk a little bit about noxacusis or pain hyperacusis, as it's also called, the neurons that are responsible for this condition are called the unmyelinated type 2 afferent neurons. Now, basically what these neurons do is they create, quote unquote, they create this pain sensation due to high intensity sounds. And they're actually shielded they are less shielded from external stimuli due to the absence of myelin. If you take a look on the diagram I have up on the screen, the myelin sheath is basically kind of like it's a shield from too much external stimuli. And in theory, basically, because these neurons are unshielded, there's a higher chance of them, I guess, becoming hyperactive or activating too much, basically. Now, obviously, as all things in the auditory system are related, these type 2 neurons are also related to the DCN. Now, a small theory, which is actually just my theory, which has not really been researched that much, because the auditory system contains feedback mechanisms where higher processing centers, like the DCN, can actually modulate peripheral sensory inputs. Reducing DCN hyperactivity might alter these feedback loops, basically leading to a decreased activation or sensitization of the type 2 afferent neurons. That's just the theory, so we don't actually know if the Susan Short device will help with noxicusis, but there's a very good chance that it will. Now let's get back to tinnitus, or specifically the hyperactivity of fusiform cells in the dorsal cochlear nucleus. Now there's 2 terms you should keep in mind, which is long-term potentiation and long-term depression of neurons. Now there's a specific thing called synapses, which I have actually on the screen above. And what synapses are is they are the connection between neurons. So the stronger connection you have, the more active or hyperactive your neurons can potentially be, and vice versa for the weaker connections. Now, long-term potentiation is basically like turning up the volume on important signals. It strengthens the connections between these neurons that are frequently activated together. This is based on a term called Hebbian plasticity. Now, I know that you're probably having a tough time, keeping track of all of these terms, but it's basically what Hebbian plasticity, it can be summarized as neurons that fire together, wire together. Basically, if 2 neurons activate at the same time, their connection gets stronger. That's long-term potentiation. But that's actually not what we want with tinnitus, because tinnitus and tinnitus spikes, etc., due to too much stimulation, long-term potentiation is triggered much more often than it actually should be. So when your tinnitus spikes from loud noise or from anything, long-term potentiation is actually happening. Now, on the other hand, what we really care about is long-term depression. It's the complete opposite. It's like turning down the volume on less important connections, or just connections in general. What this is that it weakens connections between neurons. Now, this is called anti-Hebbian plasticity. It's the opposite of Hebbian plasticity, obviously. Yes, so the connection between them weakens. Now, if you get really into detail, basically, I want to talk a little bit about action potentials. Now, this is actually a very important thing that is also discussed, in terms of habituation and how habituation works. What is an action potential? It's basically a rapid electrical signal that travels along the axon of a neuron. Now, the axon, as I showed to you in previous images, is that kind of long thing, that is covered or not covered in the case of type 2 afferent neurons with these myelin, these protection shields. Yes, so it's basically like the long body of a neuron. Now, to give a little description, there's a couple of states of the axon, or of the nerve cell. So there's the resting state. Yeah, so normally the inside of a neuron is negatively charged relative to the outside. That's called the resting potential. And when a stimulus reaches a certain threshold, it triggers the action potential. So what is the action potential? Let's get more into detail on that. So the depolarization, the sodium channels of the neuron's membrane open, allowing for the sodium ions to rush in. This makes the inside of the neuron more positive. And now there's something called the repolarization, which is the potassium channels opening, allowing the potassium ions to flow out, bringing the inside back to a negative charge. Now, there's something called the refractory period, where the neuron briefly becomes more negative than its resting state before returning to normal. During this time, it cannot fire another action potential. And there's also something called propagation, which is how the action potential travels down the axon to the next neuron or to the muscle, or etc., etc., etc. As you guys can probably already understand, tinnitus is it's basically when the potassium channels are destroyed, or not destroyed, but they're not functioning correctly, leading to too much action potential and too much propagation. So there's not enough refractory, so the neuron cannot return to its resting state. It's basically constantly activated. Now, during habituation, when you first, for example, when you first experience a stimulus, it triggers a very strong action potential, leading to a noticeable emotional response. Like, for example, when the body feels itself like in danger. Now, when you have a repeated exposure, the same stimulus is repeated over and over and over again. The neurons that are involved in sensing and responding to this specific signal, this specific action potential, become less responsive. They fire fewer action potentials. So over time, the action potentials generated in response to the stimulus, they reduce in frequency. So this is because the neurons adapt and basically become less sensitive to the stimulus. And the decreased neural activity leads to a lesser behavioral or physiological response to repeated stimulus. So overall, what is habituation? Habituation is technically the decrease in action potential frequency in response to repeated harmless stimulus, which basically means that your brain does not react to this stimulus as often or as much as it should. Like, it doesn't sense it as being in danger. Now, people who have heightened anxiety, and by the way, I'm going into areas that are not researched here, by the way. I didn't find any research on this. I'm just pretty much making assumptions about this based on my knowledge on this subject. When a person has heightened anxiety, even though the action potentials are repeated, and they should decrease, right? They should decrease in response. Like, there should be a decreased response to these action potentials. It doesn't happen. So because a person is always aware of their tinnitus due to anxiety, these action potentials, for some reason, they don't decrease. They don't decrease in response. Now, I was actually having a kind of discussion with Hamid Jillian about this, and we could not really come to a specific conclusion because this area is just not researched enough. So, like, the logical thing would be to assume that habituation is the same as long-term depression, right? But it actually is not, because there is no objective decrease in the action potentials or how they are intercepted by the auditory system. So the tinnitus doesn't actually become quieter when you habituate to it. It just doesn't trigger an emotional response. And long-term depression, which is achieved by Susan Shore's device, is technically an objective decrease in the firing rates of these neurons, or basically desynchronizing them and decreasing their connections between these neurons. So yeah, okay, I'm rambling on. Let's actually get to the stuff that is important for what you guys have been waiting for. So Susan Shore's device basically induces long-term depression or anti-Hebbian plasticity of the fusiform cells in the dorsal cochlear nucleus by precisely synchronizing auditory and somatosensory stimulation, very precisely. Now, if you want to read more about this, you can just read her research, because it would take way too long to describe in this video, and it's already long as is. Now let's get to the juicy stuff, basically. Yeah, so how people have reacted to using the Susan Shore device. Now, there's currently 4 people who are actively treating themselves with do-it-yourself devices. And I'm going to start with myself. Now, as I already mentioned in my previous video, I had a total suppression of tinnitus in my left ear. But another thing that I didn't mention is that my tones, my multiple tones that I still had, the two ones that I had left, they morphed together into a hiss, basically like a singular tone, a singular hiss. Now, I had to stop the treatment because there were some modifications to the audio file and modifications to the device itself that I needed to make. So I'm in the process of working on software to help with that. So, but everybody else is continuing their treatment. So let's get on to the second user. Now, if we move on to the DIY user number 2, he has also seen a total suppression in his left ear of tinnitus, and the right ear is absolutely diminished, he says. So without a doubt, there's tinnitus is less in his right ear as well, but not completely suppressed just yet. He also mentioned that the tones have changed, so the tones have become more clear and more pleasant. So that's something that is actually very similar to what I experienced as well. Now, this guy, he is not a super responder, so his tinnitus is not as somatic as mine. So that's why I'm assuming it's taking him a bit longer to achieve the same results as I have hypothesized previously. Now, for why the left ear becomes completely suppressed, we don't really know, but one theory is that because the placement of the neurons, as you can see on the image above, are over the cervical nerves, and the one adjacent to it is placed closer to the left ear, and everybody is doing this placement, by the way. Nobody has started experimenting with the placement yet. Maybe this is why, because the left ear is becoming like completely suppressed and the right ear is not. We don't know. We need to test it more. Now, the third user, and one thing I forgot to mention for the second user, is that the second user is also experiencing complete bouts of silence for many minutes. I would say even close to an hour post usage of the Susan Shore device. Now, this could just be residual inhibition, the total silence, but I think it actually means something. And leading up to the third user, he's experiencing the same thing. So he's experiencing total silence occasionally. There's a complete suppression of tinnitus in the left ear. And there's also an overall improvement of tinnitus in the right ear as well. So it's not just the left ear. So the quality of the sound is also becoming significantly better. And so it's actually really interesting to see how similar all of the effects are, of the treatment on us. Yes, so he also mentioned that this is another thing, is that he got, in the first 2 sessions, he got tinnitus reductions in both ears. His right ear was the one that was damaged, and the left ear, his tone was completely suppressed, and the second pure tone was reduced also by 50 to 60%. And his head tinnitus was maybe like a 30 to 40% reduction. And the right ear is also, actually, he didn't clarify what tones he had specifically in his right ear, but there was also reduction there as well. Now, the next user, who's the newest one, has done only a couple of sessions, a bit more than a couple of sessions, but it follows a similar pattern. The quality of the tinnitus has morphed into a hiss, kind of like a shh instead of a tonal one. And he says that it's like his T is confused, which I assume is, the antihebian plasticity in action. And he also had a complete suppression of his left ear. So this is really interesting stuff. So basically there's not much to say on the fourth user, except that also tinnitus in the left ear has been completely suppressed, and tinnitus in the right ear, or the tones, have morphed into a more pleasant sound. But since all of us still have a long way to go, especially me, we're just going to be waiting for future results. So that's basically it for today. if you have any questions, for example, why am I not sharing this information or openly? Why am I not sharing the blueprints to the device? Well, that's because I don't want to be arrested and fined for patent infringement. That's one thing. So please don't ask about that anymore. The second thing is, where can you ask me about these, even further about this? You can join my Discord server in the description and in the comments, and you can directly personal message me about this, because DIY discussions in the server are not allowed. So you can just find me through the through my Discord server, and if you have any questions about the functionality of the device or anything related to DIY, you can message me there. But I'm not going to be releasing any blueprints, and I'm not going to be like explaining how to build it or anything like that. It's just for morbid curiosity purposes only. Okay, so that's it for today. I'll see you guys later. Peace.